In a few years, these newly printed notes will become worthless toilet paper. The stacks of dollar bills you have at home were made in this printer. The Federal Reserve has been printing money like wild in an effort to pay down the roughly 37 trillion US debt. While it is not new for the government to print money to cover some debt, what is new is that 40% of existing US dollars have been printed in the last 12 months alone. There are only 2 locations in the entire United States where US banknotes are produced, in Fort Worth, Texas, and Washington, D.C. Fort Worth-made banknotes can be identified by this small symbol on the note. There are currently approximately 65 billion notes in volume circulating among people, and on an average day, over $30 million worth of banknotes are produced in the United States. The US government has no direct influence on the number of banknotes printed. The number of new banknotes is determined and ordered by the Federal Reserve. In short, if the Federal Reserve wants to change the number of notes in circulation, it has to instruct the Bureau of Engraving and Printing, which then prints the notes. These armored cars are actually vaults on wheels, delivering banknotes between federal banks. They're designed to be bulletproof and to withstand a grenade blast. So the actual value of the notes in your pockets is determined by the total number of notes in circulation. In times of crisis, the Fed prints money to boost the economy. The average wage for these factory workers is just under $37 per hour. Believe it or not, in 1930, you could buy 8 movie tickets for $1. In 1960, the power of $1 was such that it could buy you 5 hamburgers. And 25 years ago, in 2000, a gallon of gas cost only $1 on average. So let's take a look at how American banknotes are made. U.S. currency begins with this design process, which is an interagency effort between the Federal Reserve, the U.S. Department of the Treasury's Bureau of Engraving and Printing, and the U.S. Secret Service. The Secretary of the Treasury has final approval of designs of Federal Reserve notes. Then, it begins by blending premium cotton and linen fibers to create a unique and durable paper. This special blend not only gives the notes their distinctive texture, but also ensures that they can withstand everyday use. Next, the paper undergoes a series of security enhancements, including the incorporation of watermarks and security threads, which help prevent counterfeiting. Once these measures are in place, the paper moves on to the printing press. The first stage involves applying a multicolor background using an offset printing press, which prints both sides of the note simultaneously with exceptional detail and vivid colors. Then, the intaglio printing process takes over, where engraved plates are used to create a raised texture and intricate designs. Intaglio is the next layer of the printing process for the denominations that went through offset, and the first phase of printing dollar bills. Bills last longer when they are used less frequently, so higher denomination bills tend to last longer because they are used less often than lower denominations like $1 bills. Here, ink is applied to the engraved plate. U.S. currency also contains fluorescent inks that are visible only under ultraviolet light. These inks are used in the security thread and some microprinting elements. After a thorough manual inspection to ensure perfection, the bills are cut, bundled, and prepared to enter circulation. Every bill that comes off the assembly line is carefully crafted, incorporating numerous features that make counterfeiting nearly impossible. Right now, you are watching the belt production of banknote paper processing. U.S. currency is not printed on typical paper, made from wood pulp. Instead, it is made from a special blend of 75% cotton and 25% linen. Dandy roll is a specialized part of the paper machine that embeds various security features into the paper, such as watermarks and security threads. Each U.S. bill is embedded with red and blue security fibers that are distributed randomly, adding an extra layer of protection. While the $1 bill does not include all of the features seen on higher denominations, other bills have more advanced security measures. These include subtle background colors, larger denominations featuring a portrait watermark visible under light, and ink that shifts color when tilted. These giant rolls of special banknote paper will produce billions of banknotes when printed. The distinctive green color of U.S. paper currency was chosen because green ink was abundant and resistant to chemical fading, which made the notes harder to counterfeit. While U.S. paper money is mostly made of cotton and linen, Other countries like Canada and Australia have adopted polymer notes, which are more durable and harder to counterfeit. These employees are trained to operate these special machines, which produce the designs that are then stamped onto banknote paper. Their main job is to control the entire banknote production process. The $1 bill has a hidden symbol above the pyramid on the Great Seal. If you look closely, the eagle on the $1 bill holds an olive branch in one talon and 13 arrows in the other, symbolizing peace and strength. The $100 bill stands out due to its advanced features. For example, the blue ribbon woven into the bill provides an extra layer of protection against counterfeiters. This 3D ribbon shifts colors when tilted and adds an extra layer of security. Other microprint features, such as tiny text on Benjamin Franklin's collar, are designed to be hard to replicate and help identify counterfeit bills. Throughout the production process, the banknotes are packaged into larger bundles. These bales are then handled by an automated arm manipulator. The background designs of the $50 and $100 bills are distinctive to each note. For example, the $100 bill features an image of the Independence Hall in Philadelphia, while the $50 bill features the U.S. Capitol building. In the fight against counterfeiting, there are 65 steps in the banknote production process. The more complicated, the harder to counterfeit. The average salary for employees in this factory is around $37 per hour, depending on their experience. Federal Reserve estimates that the total amount of currency in circulation is approximately 2.4 trillion US dollars. Right now, you are watching the checking, counting, and packaging of the banknotes used. These particular banknotes have been assessed as no longer used by the banks. They must therefore be withdrawn from production. After packaging, they will be sent for disposal. The recycled parts of the notes are often used to make souvenirs for visitors to this U.S. banknote factory. The most widely used is the $100 note, but the reason is not its use in the United States. Approximately 80% of the $100 bills are found outside the United States. $5 bills typically last around 2 to 3 years in circulation before they are worn out to the point of needing replacement. The production line is almost completely automated. Employees only keep it running and replenish paper and ink. On U.S. banknotes, you'll find a series of letters and numbers like K11 or E5. This is usually located on the bill near the Treasury seal or the serial number. The letter corresponds to one of the 12 Federal Reserve banks. Each of these banks is designated by a specific letter, and these letters are used to indicate which bank issued the bill. The letters are as follows. A represents Boston, B stands for New York, C is for Philadelphia, and so on. Designing the look of banknotes and fine-tuning the details takes many months for specialist designers. Everything on the banknotes has to be perfect before they are printed by the millions. These employees had to pass a comprehensive security exam to get the job. There is a rigorous screening of workers when they go home. The team of people who produce American money is huge. Around 1,500 employees and contractors work at facilities in Washington and Fort Worth. The production of a single sheet of banknotes takes several days and uses a number of printing machines and printing techniques. While the Bureau of Engraving and Printing issues new bills, it is nearly impossible to track how many exact bills are in circulation due to their movement between individuals, businesses, and foreign nations. U.S. currency is often seen as a symbol of economic power. The U.S. dollar is the world's primary reserve currency, meaning many countries hold large reserves of U.S. dollars as part of their foreign exchange reserves. These yellow robots, called automated guided vehicles, are used for the automated transport of extremely heavy boxes of banknotes. They are easy to program and very reliable. These red armored trucks from Dunbar Security Solutions are used to transport hundreds of millions of dollars between federal and other banks. Once transported to the destination bank, the millions of dollars in notes are immediately moved to a massive vault where they begin to be counted and sorted. Right now, you're watching what it looks like inside a huge vault at the Federal Reserve Bank of St. Louis. It is one of 12 regional reserve banks that, along with the Board of Governors in Washington, D.C., make up the United States' central bank. Missouri is the only state to have two main Federal Reserve banks because Kansas City also has Fed Bank. The currency is stored in high-security vaults that are designed to prevent unauthorized access. The vaults are equipped with multiple layers of physical security, including reinforced steel doors, advanced alarm systems, and 24/7 surveillance. The value of the US dollar can be affected by inflation, which occurs when too much money is printed, lowering the currency's purchasing power. But Bitcoin has a fixed supply of 21 million coins, which means no new Bitcoins can be created beyond this limit. This makes it resistant to inflation in the traditional sense. Please let me know in the comments section what your opinion is on this. Right now, you are watching more and more dollar bills being printed, reducing their real purchasing power. It makes you wonder if Bitcoin is the solution. Many of these facilities use biometric scanning systems, for example, fingerprint or retina scanners, and multi-factor authentication to ensure that only authorized personnel are able to access sensitive areas. Because the US dollar is used globally, the Federal Reserve can print money without causing the same level of inflation as would occur in a smaller, less used currency. However, overprinting still poses risks, especially if trust in the dollar begins to erode. The US has a significant national debt, which means it borrows large sums of money from both domestic and foreign investors. Printing more money to finance debt can lead to inflation, particularly if investors lose confidence in the US government's ability to manage its debt. The Federal Reserve receives currency from banks across the country, sorts it, and checks for damaged or worn-out bills. Bills that are identified as unfit for circulation are sent to a Federal Reserve processing center for disposal. Once the damaged bills are collected, they are shredded in secure facilities. The shredding process completely destroys the bills, turning them into small pieces of paper. Once the old and damaged bills are destroyed, the Bureau of Engraving and Printing issues new bills to replace them. In fact, about 7 billion new bills are printed each year to replace the old ones that are taken out of circulation. The BEP even has a specialized facility for processing destroyed paper money in a way that is secure and environmentally safe. The dollar was originally tied to the value of gold through the gold standard. However, the US officially abandoned the gold standard in 1971 under President Richard Nixon, which made the US dollar a fiat currency, not backed by physical reserves. Although about 40% of Americans are cashless in their weekly spending habits, more than $2.4 trillion of US currency is in circulation. The phrase, "In God we trust," was first added to US coins during the Civil War, and later was included on all paper currency in 1957. It is now the official motto of the United States. This is what an extra powerful banknote counter looks like, which counts the notes and then packs them in the desired packages. US bills feature portraits of historical figures. For example, George Washington appears on the $1 bill, Abraham Lincoln on the $5 bill, and Alexander Hamilton on the $10 bill, though he was never president. Benjamin Franklin appears on the $100 bill. The designs on US paper money have evolved significantly. The portraits of US presidents and notable figures have remained, but security features, including watermarks, security threads, and micro-printing, have been added to combat counterfeiting. The pre-prepared banknote paper is loaded onto pallets and stored in a central warehouse. These warehouses within Fort Worth and Washington have the highest possible protection as well as proper insurance. Please let me know in the comments section if you would be interested in working in the factories where the banknotes are produced, or if you prefer another job. Despite all efforts, all these newly produced banknotes end up as waste after many years. So this is the United States Mint in Philadelphia. The U.S. Mint works closely with the U.S. Treasury Department and Congress to select designs for new coinage. The U.S. Mint uses specific metal alloys depending on the type of coin being produced. For example, pennies are made from copper-plated zinc, while quarters are composed of a cupro-nickel alloy. The raw metals are often purchased from suppliers and melted down to form ingots. The molten metal is rolled into thin sheets, which are then punched into small round blanks or planchets that will become coins. These blanks are roughly the size and shape of the final coin, but are not yet imprinted with the design. The planchets are placed into the coining press, which is a machine capable of striking large numbers of coins quickly. Each planchet is fed into the press automatically. The dies are then pressed onto the planchets under extreme pressure, leaving the design on both sides of the blank. This process also stamps the coin with its denomination and mint mark. For example, P for Philadelphia. Coins such as dimes, quarters, and half dollars have ridged edges, which are added to prevent the practice of clipping coins to remove small amounts of metal. The edges are milled after the coins have been struck. The coins are thoroughly inspected for defects or errors. Any coins with imperfections are removed from the batch. In some cases, coins are also polished to give them a smooth, shiny appearance, especially those intended for collectors. And now you are looking at how gold bars, gold coins, and gold jewelry are mined and produced. Fort Knox, located in Kentucky, is one of the most famous and secure gold reserves in the world. While it is not a gold production facility in the traditional sense of mining or refining gold, it plays a pivotal role in the U.S. gold industry as the central repository for the nation's gold reserves. Fort Knox is primarily known as a gold depository and is owned and operated by the U.S. Department of the Treasury. Last year, global gold production was approximately 3,000 metric tons. This marks a decrease from previous years, largely due to declining ore grades and resource depletion at established mines. The top gold-producing countries have remained largely consistent over the years, with a few fluctuations. The largest producers are China, Australia, Russia, the United States, and Canada. Together, these 5 countries account for around 50% of global gold production. The US dollar was originally tied to a specific amount of gold under the gold standard, but this system ended in 1971 when President Richard Nixon took the US off the gold standard, marking the beginning of the modern fiat currency system. Borax is a compound that plays an essential role in the gold refining process, particularly in artisanal gold mining and small-scale operations. It is often used as a flux in gold extraction because of its ability to lower the melting point of metals and improve the efficiency of refining processes. Switzerland is the global leader in gold refining, accounting for about 70% of the world's refined gold. Other major refining hubs include China, India, and the United Arab Emirates. In 2024, Switzerland refined about 1,200 metric tons of gold, making it a central player in the global gold market. As of the latest data, the total amount of gold held at Fort Knox is approximately 147 million ounces of gold. This accounts for around 2% of the world's official gold reserves. Based on the current gold price, the total value of the gold stored at Fort Knox is estimated to be over $300 billion. With an estimated 200,000 metric tons of gold ever mined, at current prices, the total value of all gold ever mined is roughly $17 trillion. Gold is a crucial material in the electronics industry, used for connectors, switches, and other components due to its excellent conductivity and resistance to corrosion. Around 10% of annual gold demand comes from this sector. While both the euro and US dollar have unique strengths, euro banknotes tend to be more secure, more durable, and more artistically diverse. Their advanced security features, better environmental sustainability, and the diverse design themes reflecting Europe's architectural heritage make them a standout in terms of both functionality and aesthetic appeal. The European Central Bank regularly monitors the volume of banknotes in circulation, with over 25 billion euro banknotes in circulation as of 2025, totaling several trillion euros in value. The production of euro banknotes involves a significant financial investment. For example, in recent years, the cost of producing each note has ranged from 0.03 euros for smaller denominations, like the 5 euro note, to 0.11 euros for larger ones, like the 100 euro note. The total cost is determined by factors like materials, security features, and the number of notes in circulation. Euro banknotes feature multiple advanced security features, such as a hologram with a portrait of Europa, watermarks, microprinting, raised print, and a security thread. The use of a security thread visible in the light and a unique design embedded in the paper makes them harder to counterfeit. Euro banknotes generally have more advanced and varied security features designed to prevent counterfeiting, making them harder to replicate than US dollar notes. Euro notes are made from a special cotton fiber material, which gives them a distinct feel and makes them more durable. These notes are more resistant to wear and tear than traditional paper-based notes. Once the large printed sheets of banknotes have been fully inspected, they are cut into individual banknotes. These notes are then stacked and packaged for delivery to central banks or the European Central Bank for distribution. The 20 euro banknote is part of the second series of euro banknotes, often referred to as the Europa series, which was introduced by the European Central Bank starting in 2013. The 20 euro note, like all euro notes, is made from a special cotton-based paper rather than regular paper. When you hold the note up to the light, you can see a watermark that shows the portrait of Europa, which matches the hologram. This is a prominent anti-counterfeiting feature. Multiple printing techniques are used to produce the 20 euro note, including intaglio printing, offset printing, and letterpress printing. After printing, the large sheets of banknotes are carefully cut into individual notes. Each 20 euro note is then inspected for quality and security features to ensure no imperfections or counterfeit attempts. The notes are then packaged and sent to central banks or other issuing institutions. Once the notes pass the quality checks, they are distributed to banks and financial institutions within the Eurozone, where they will enter into general circulation for use in day-to-day transactions. Swiss banknotes are made from a special cotton paper that's durable and resistant to wear, making them last longer in circulation. They also incorporate security threads and watermarks that are woven into the paper, not just printed on it, adding an extra layer of authenticity. The designs on Swiss banknotes are a tribute to Swiss culture, history, and innovation. Each note features famous figures, landmarks, or themes that represent different aspects of Swiss society. For example, the 1,000 Swiss franc note honors Le Corbusier, a renowned Swiss architect. The Swiss National Bank is responsible for overseeing the design, production, and distribution of Swiss banknotes. Security printing is done at a specialized Swiss National Printing Works, Swiss Mint, where printing is conducted under high security to prevent counterfeiting. Swiss banknotes are among the most secure and well-designed currencies in the world, blending cutting-edge technology, craftsmanship, and Swiss pride in every detail. The Swiss National Bank educates the public on how to spot counterfeit notes through an online platform and public service announcements. They emphasize the importance of feeling, tilting, and looking to verify a banknote's authenticity. Diamonds, while naturally occurring, can also be manufactured in a laboratory setting. and their production process involves a combination of high technology and meticulous craftsmanship. Natural diamonds form over 1 to 3 billion years deep within the Earth's mantle, around 90 to 120 miles below the surface. The manufacturing of diamonds can be broken down into two primary methods: natural diamond extraction and synthetic diamond creation. However, we'll focus here on how diamonds are made in the context of both natural and synthetic production. Whether natural or synthetic, once a diamond has been produced, it must undergo a meticulous cutting and polishing process to transform it into a piece of jewelry. The conditions required for natural diamond formation include extreme pressure, about 45 to 60 kilobars, which is 45,000 to 60,000 times the atmospheric pressure. The most expensive diamond ever sold is the Pink Star, a 59.60 carat pink diamond that sold for $71.2 million at auction in 2017. The process of making jewelry from gold is a detailed and intricate journey that transforms raw gold into stunning wearable art. It begins with the sourcing and refining of gold. Once the gold is ready, the next step is the designing phase, where jewelers create detailed designs, often using advanced computer-aided design software. The casting process follows, where a wax model of the jewelry piece is made and coated with a layer of investment material, such as plaster or ceramic, to form a mold. The wax is then heated, causing it to melt away and leave a cavity in the mold. After all finishing touches, the jewelry undergoes a final inspection to ensure it meets quality standards. This includes checking for any defects, ensuring stones are securely set, and verifying the overall finish of the piece. Although credit cards have no value in themselves, through them the value of property is converted into things. That is why you are now following the production process of credit cards. The manufacturing process of credit cards involves several intricate steps to ensure that each card is functional and secure. From the design to the final delivery, each phase is carried out with precision. Credit cards are typically made of plastic, usually polyvinyl chloride, although some premium cards may use materials like metal or composite materials. PVC is preferred due to its durability, flexibility, and cost-effectiveness. The plastic used in the production is highly resilient, ensuring the card can withstand daily use and the wear and tear that comes with carrying it in wallets or purses. The card design, including the issuer's logo, cardholder's information, and any background design, is printed onto the card using techniques like offset printing or UV printing. This printing process ensures the text and images are of high quality and highly resistant to fading. If the card uses raised text, for example, the cardholder's name or card number, embossing is done. This involves using heat and pressure to create raised characters on the card. Some security elements, such as holograms, microtext, and UV features, are also printed at the stage to prevent fraud. For traditional credit cards, a magnetic stripe is added to the back of the card. This stripe contains encrypted data, such as the cardholder's name, card number, and account information. The data is stored magnetically, which allows it to be read by a card reader when swiped. For more secure transactions, an EMV chip, EuroPay, MasterCard, and Visa, is embedded into the card. This small microchip contains encrypted data that makes the card difficult to clone, enhancing security for card transactions. For some types of credit cards, a personal identification number is generated and linked to the card. The PIN is typically sent separately to the cardholder for added security. Cards are often subjected to stress tests, such as bending, to ensure they are durable and able to withstand regular handling. Credit cards are tested for compliance with the latest security standards and are verified for anti-counterfeiting measures. After the cards are fully personalized, they are carefully packaged for distribution. Each card is usually placed inside an envelope or sleeve that contains important information about the cardholder's account, terms, and conditions. Sometimes, cards are sent along with a welcome kit or cardholder agreement. The completed credit cards are sent out to the customer either through direct mail or distributed to the issuing financial institutions, such as banks or credit card companies, who then mail them to card holders. The manufacturing of credit cards involves a complex mix of security measures, material science, and technology to ensure the cards are functional, durable, and resistant to fraud. Every stage, from design to final distribution, is carefully managed to meet industry standards and protect cardholders from identity theft and counterfeit activity.